So differential calculus, we are looking at it from the point of notes first. And then in our second lecture, that's when we'll be answering the tutorial sheet. So we have about 30 pages to discuss, so that in the next class, as we answer the tutorial sheet, no one will be behind. And it will help us to be fast when studying these things. The first concept here is the tangents and normals to general plane curves. That's the first thing here. The other things are known. The derivative of a function, if the function is differentiable, the first one is what we call the gradient. And the second one is just a second order derivative. The third up to the nth. So 2.1 tangents and normals. To general curves, to general plane curves. So if I have a function f of x, its derivative, which is df dx, evaluated at x naught. So meaning that on the left here, I can write as f prime of x naught, or the derivative of f at x naught. This guy is called the gradient of the curve at the point x naught comma f of x naught. Let me give you an example. F of x is equal to 4x power 3 plus 7x squared plus 3x plus 4. At a point at x is equal to, say, -1. Find the gradient of f of x at x is equal to -1. So what we'll do first is we'll differentiate f with respect to x, and then substitute x is equal to -1. So first we differentiate. So what is the derivative of this function? It is 12x squared plus 14x plus 3. Answering now the gradient at x is equal to -1, we'll substitute in this derivative x is equal to -1. That is 12 -1 squared plus 14 -1 plus 3, which is equal to 12 minus 14 plus 3, which is 15 minus 14, which is 1. So the gradient, remember, you will write something like this: mx plus c. What we are calling the gradient now is m. So m is equal to 1. Remember, a gradient is always a gradient of a straight line that is touching the curve at that point. So when you're talking of the gradient, we mean, maybe I have something like this. I'm looking at the gradient at -1, meaning I want the gradient of this line here that is touching the curve at -1. Okay. So one thing you must know also is that the gradient of a line, so you must note that the gradient of a line parallel to the x-axis is always 0. Because the gradient of the x-axis is 0. And so the gradient of the line that is parallel to the x-axis is 0. So that the gradient of two lines that are parallel to each other will be equal. So I've added the gradient of two parallel lines. Is equal. Is the same. Is the same. All right. So two parallel lines have got the equal gradient. Yeah, that one was okay. And this is how you find that. This is how we find the gradient. And then a line that touches the curve at only one point. A line that touches the curve at only one point is called the tangent line. By definition, a tangent line is a line that touches the curve at only one point. So that a line which cuts the curve at only one point and is the term I'm looking for here. And is perpendicular to the tangent line. Yeah, I found it. Is called the normal. The normal line. And the gradient of the normal is, if the gradient of the tangent is mt, the gradient of the normal is mn. When you multiply them, they will give you -1. So that the gradient of the normal is just -1 over the gradient of the tangent. Like this. This is how we obtain the gradients of. So the mt and the mn is equal to -1 when you get the product. So keep these very, very important. And a line will only be normal on a condition that it is perpendicular to the tangent, not just to another line, but to the tangent line. Then it becomes normal to the whole curve at that point. So I'll give any examples. Now I give you also an example from the notes. Example 2.11. 2.11 example. 2.1.1. Find the tangent and normal lines to the curve x squared minus xy plus y squared is equal to 7 at a point -1, 2. So first thing, you need to find dy dx so that you can get the gradient of the tangent. The equations will always be y is equal to mt x plus c, or y minus y naught is equal to mt x minus x naught. The two equations are the same. Okay, so let's find the mt. So we differentiate this guy with respect to x. So it will be 2x minus, it will be 2x minus y minus x dy dx. I'm using implicit there. When there's xy, it's like you're doing the product. And then plus 2y dy dx, making sure that Whenever you differentiate y, you put dy dx is equal to 0. Factor out dy dx, we'll get 2y minus x is equal to y minus 2x. I've taken this guy and this one the other side. And then divide 2y minus x, divide 2y minus x. So our dy dx will be y minus 2x over 2y minus x. Evaluated at the point -1, 2, we'll get 2 minus 2 -1 over 2 minus -1. That is 2 plus 2 over 4 plus 1, which is 5 over, which is 4 over 5. So 4 over 5 is the MT. So y is equal to 4 over 5 x plus c. Get the same point. Excuse. So get the same point for the values of x and y. So y is 2 as x is -1 at this point. So that here we get c is 2 plus 4 over 5. I'm taking this other side, and because it is negative, it will be positive there, over 1, so that we have 5 down and get 10 plus 4, which is 14 over 5. So c is equal to 14 over 5. So the tangent curve, the tangent equation, I mean, is y is equal to 4 over 5x plus 14 over 5, which you can as well write as 5y is equal to 4x plus 14, or 5y minus 4x minus 14 is equal to 0. That's your line. Then the normal line. Here where we used 4 over 5, for the normal now we are saying MT, MN is equal to -1, meaning that MT is 4 over 5, MN is unknown. Multiply by 5 over 4, multiply by 5 over 4. So we have MN is equal to -5 over 4. We get back here and say this guy is just MN x plus c. What does that mean? It means that this is just the same as -5 over 4x plus c. So that if y is known to be 2 and x is known to be -1, then we'll quickly know what c is, because c will just be 2 minus 5 over 4. And this is -1 over 4. So that y is equal to -5 over 4x minus 1 over 4, which is the same as 4y plus 5x plus 1 is equal to 0. So this is the normal line, as the tangent line is here. This is how you evaluate and get and get those guys there. Okay. An application question. An application question. An application question is find the equations of the tangent. Find the equations of the tangents with slopes, meaning with the gradient -2/9 to the ellipse 4x squared plus 9y squared is equal to 40. Find the equations of the tangents with slopes, with a slope -2/9 to the ellipse, that guy is equal to 40. So what do we know here? We obviously know that the slope is a derivative of this guy here. That is what we call the slope. So automatically, if we are to differentiate this, it will give us 8x plus 18y dy dx is equal to 0. So dy dx is going to be -8x over 18y. Divide 2 on top there, and down you get -4x over 9y. Okay. At a point which is unknown, we have that -4x. Suppose the point is x0 and y0 there. So x0, y0. This guy will give us -2/9. So what does that mean? It means that if you cross multiply here, 9 throughout, we have -4x0 over y0 is equal to -2. If we also multiply the y, we get this guy -2y0. Divide throughout by -2, we'll get 2x0 is equal to y0. Okay. So what you are doing here is that you're just assuming that wherever, this is an ellipse. So I send it at 0,0. So we have something like this. So we're assuming that there's some tangent somewhere whose gradient is -2/9. That's what that tangent line is. So if it's here, and its gradient is that at that point, we are calling that point x0, y0. Now, because the point lies on the ellipse, it must be true that since we have said that y0 is equal to 2x0, it should make sense that when we go in that equation there and substitute, it must be satisfied. So we say 4, so x now becomes x0, 4x0 squared plus 9, where there is y, we are going to put 2x0 squared is equal to 40. So this 4x0 squared plus 4 by 9. So I know I can multiply 4 by 9, but then I want to multiply so that our work will be easy, because we are seeing this 4 here. this 4 there, this 4 here. So now we have x naught plus 9x naught squared. This 2 is squared. This guy is x naught. Okay, so x naught squared plus 9x naught squared is equal to 10. So we are getting 10x naught squared is equal to 10, implying that x naught squared is equal to 1, so that x naught is plus or minus 1. So y naught, when x naught is 1, y naught will be 2 by 1, which is 2, giving us a point 1, 2. Or y naught is, when x naught is negative 1, y naught is 2 multiplied by negative 1, which is negative 2. So we are getting negative 1, negative 2. So we have these 2 points at which the tangent is passing through. So we can find the equation of the tangents. So one of the equations will be y is equal to the given gradient, negative 2 over 9 x. Is it true that Joe has been waiting? Let me check if he's here. This was 17. I've been waiting, but no hope. Is it true? The session is even on. The session is on. Your mic is off. Okay. Okay. So this plus C. But what is C? So we need to know C. So you get a point, substitute in here. So when this guy is 2 and the other one is 1, we can know the value of C. That will be 2 plus 2 over 9 is equal to C, simplified as 11 over 9, meaning that this equation here is y is equal to negative 2 over 9x plus 11 over 9. Another one, y is equal to negative 2 over 9x plus c. This time when this guy is negative 2, the other one is negative 1, giving us a c after evaluating. So we'll get negative 2 minus 2 over 9 should give us a c, which is negative 11 over 9. So we also have y is equal to negative 2 over 9, negative 2, I'll write it from here. Y is equal to negative 2 over 9x minus 11 over 9. If you want to cross multiply, this can be written as 9y is negative 2x minus 11. The other one could be written as 9y is equal to negative 2x plus 11. So these are two tangencies, the equation of the tangent lines, line 1 and line 2. This is a good time to ask. So in a 2-hour session like this one, and you have no questions, you deserve to be given a question to try. And there are so many questions, so that
So I'm asking for the previous board.
Are you done with it?
Yes, thank you.
Okay. So you deserve, since there are no questions, meaning that there's your understanding of these things. So let's see. Let's see this one. One, find the tangent and normal line to the curve, y squared minus 4 is equal to x squared minus 5 at the point root of 5 comma 0, and the other one, this one now an easy one. An easy one is x squared over 9 minus y squared is equal to 1 at x is equal to 6. Hint, substitute x is equal to 6 in the equation and get the corresponding y values. Then 2, the tangent line to the curve y is equal to ln root of x plus b at the point 5 comma ln 5 is parallel to the line 8y is equal to 15 plus 2x. Find A and B. And B, find the equation of the normal line to the curve at the point 5 comma ln 5. So we have, this is 1744. So I'll give you up to 18, and there's not much work here. I'll give you up to 1805. So you have 10 minutes, 20, I haven't given you enough to find this. So At exactly 1805, we'll start again. So you should have, even if you fail to send a solution, you can keep it, because our first thing to do is to solve these questions and see if you have gotten them correct. Please do. Don't tell yourself that it's hard and then it will be hard for you to learn if you don't try. So I told you that here, we said that the gradient of two parallel lines is the same. So two parallel lines have same gradient. And we have a question here that is saying the tangent line to the curve at that point is that. At that point is parallel. The tangent line to the curve y is equal to that. At this point here is parallel to the line 8y is equal to 15 plus 2x. So this tells you that this equation, the gradient of this equation, is the same as the gradient of, yeah, you've known now. Okay, you can start answering up to 1805. We'll get back and continue.